Today in our physics chapter, system of particles and rigid body or rotational motion. Here the numerical is based on a center of mass. The center of mass of n particles having a masses m1, m2 dash mn and their respective distance from the center of mass are r1 vector, r2 vector dash rn vector. Therefore, RCM vector is equal to m1 r1 vector plus m2 r2 vector plus mn rn vector divided by m1 plus m2 plus mn. Using this formula, we do solve this numerical. The numerical is like this way, just you can see here. Find the center of mass of the three particles at the vertices of the equilateral triangle. The masses of the particles are 100 gram, 150 gram and 200 gram. Respectively, each side of the equilateral triangle is 0.5 meter long. Now we can say, for simplicity, we to consider here the triangle. This is a triangle whose one vertex is at the origin and mass is here 100 gram. This whole distance is 0.5 meter. That is O, A and B. Here it is coordinates are 0.50 and here coordinates are 0.5 cos 60 because this angle equilateral triangle 60 degree and 0.5 sin 60. Now we look at the center of mass here, RCM. So we know that here that is the RCM is equal to M1 R1 plus M2 R2 plus M3 R3 divided by M1 plus M2 plus M3. Now therefore RCM in xy plane, so we can write here RCM is equal to M1, that is here, that is 0, M1 is 100 into R1 here, this is R1 with position vector R1, this is R2 and this is R3. So writing here, that is 0, 0 plus 150, 0.50 plus 200, 0.5 cos 60 and 0.5 sin 60. Divided by 100 plus 150 plus 200. Now simplifying, we do get here. Therefore, RCM is equal to, now this coordinate will be 0, so finally you can write here that is x coordinate. First we will write x coordinate, so here 150 into 0.5, so that is a 75 plus, now first here that is 200 into 0.5 into cos 60 means here 1 by 2 comma, second here we can write here 0.5 into sin 60 means root 3 by 2 into this, that is we have 200 divided by 450. Now simplifying here, that is that will be cancelled by, that is 100. So finally we can get here 50. So we can get here RCM is equal to 50 plus 75 divided by 450 comma, this here 200 will be multiplied here also. So finally, so this 2 will be here 100. So simplifying, we will get here, this will be 5 and 10. So we can write here 50 root 3 upon 450. Now we have to solve this here. We get 125 divided by 450 comma 50 root 3 divided by 450, that is a meter. Now simplifying again, we have to get here RCM is equal to, now here you can see here, that is this will be cancelled here, that is 25 5s are, and here 25 1s are, and here it is 20 is 8s are. So we can get here 5 upon 80, and here it is 100 we cancel, this will be 9. So we can get root 3 upon 9 means here 3 into root 3 into root 3. So root 3 will be cancelled, therefore RCM is equal to 5 upon 80 and 1 upon 3 root 3 meter. Now again we simplify, we have to get here, again we have to simplify, that is equal to 0.28 and 0.19 meter. So this way to solve this numerical. In this numerical equilateral triangle, whose vertices has a mass is 100 gram, 150 gram and 200 gram. For simplicity, we to keep the one vertex as the origin of the xy plane, and that is vertices of the one origin O is 0, 0 and mass is 100, and then A second vertex is having mass 150 gram and vertex is 0.50, and third that is a B having a mass 200 gram and coordinates are 0.5 cos 60 and comma 0.5 sin 60. Now here we have to find out the RCM. Therefore RCM is equal to M1 R1 plus M2 R2 plus M3 R3 divided by M1 plus M2 plus M3. Keeping the value of mass and their respective position vector, that is R1 is 0, 0 unit and R2 is 0.5 0 unit and R3 is 0.5 cos 60 comma 0.5 sin 60 unit. Now keeping this, finally we can get RCM is equal to 100 into 0, 0 plus 150 in bracket 0.50 plus 200 in bracket 0.5 cos 60 comma 0.5 sin 60 upon 100 plus 150 plus 200, that is 450. Now we have to solve here x coordinate and y coordinates and divided by 450 and simplifying at the last we will get RCM is equal to, that is a 5 upon 18 and 1 upon 3 root 3 meter. Now again we do fraction, we to get RCM is equal to in bracket 0.28 comma 0.19 bracket over into meter. So this way to understand this numerical. Thank you.